In this video, we'll be studying variation of impedance with angular frequency, and we'll talk about resonance. We'll be solving questions by a phasor method as well as a method known as complex number method. So first of all, capacitors and inductors are called wattless component of the circuit as no heat is dissipated, no power is dissipated through them. So they store energy, they do not dissipate it. So the only component that dissipates heat is resistance. These are called C and L are called wattless component. Okay. So variation of Z with angular frequency. As Z approaches 0, XC approaches infinite, so does the Z. And as omega reaches to a very large value, we can say that XL approaches to large value and so does the Z. So we can say the curve should be similar to that. This is not a parabola, this is a non-uniform curve, non-symmetric curve. So just I roughly drawed it. So Z is minimum at a particular value. We can say for that particular value, current will be maximum because Z is minimum. So we can say for that XL minus XC should be 0, as you cannot change R by changing Z. But to minimize Z, XL and XC, if they are equal, then the Z will be minimum because omega has no control on R. So we can say for minimum value of Z, XC and XL will be equal, so they will completely cancel each other and Z will be equal to R. If we equate them, 1 by omega C is equal to omega L, we get the omega naught as 1 by root LC. This is also known as resonating frequency. So at resonance, what are few important points? Resonance, phase difference between voltage and current becomes 0, as XC is equal to XL tan phi, which is XC minus XL by R, will be 0. You can say phase difference is 0 between voltage and current. It also means that Z will be minimum, which is equal to R. We see voltage across capacitor will be equal to voltage across inductor. Current will be maximum, which is V naught by R. Power factor, which is cos phi. I just derived it later. Cos phi is maximum. Maximum power factor will be at resonance. So all these terms means resonance, or if resonance is there, all these terms will be satisfied. So power factor, what is power factor? Power factor is a term, is a factor that comes in addition to V into I. So that's why we call cos phi as a power factor. Power factor, instantaneous power is given by voltage multiplied by the current. So we have instantaneous voltage as this, instantaneous current as this. When we average them, we get this average of this. This is a variable thing. We just do some mathematics and get the value as half V naught I naught by 2 cos phi. This can be written as V naught by root 2 I naught by root 2 into cos phi. So Vrms Irms cos phi. Average power is given by the product of these three. This is an additional factor which is odd because we know power as product of V and I. This factor is additional, so we call it as power factor. In this, we are solving a circuit in which XL, XC all are given and the voltage is given as an 200 voltage AC having frequency 50 Hertz. So first of all, we have to find Z, L, C, omega, Vrms, Vmax. So we can say omega is 2 pi into frequency 100 pi, XL is omega L, omega is given 100 pi, L is given to you, which is 3. This XC is also can be calculated. So sorry, xc is given, you can calculate c from xc, and from xl you can calculate l. And z is given by this result r square. This result has derived from Pythagoras theorem using impedance triangle. You must have watched the earlier video of alternating current before watching this. So it will be 5 ohm, power factor not asked, but we have calculated it as 3 by 5 r by z. Phi is 53 degrees, so current will uh, ice, as the capacitance is more, current will lead by an angle of 53 degree. Okay, vrms is 200 given. Vmax is vrms root 2, maximum voltage by root into root 2 is the maximum. Oh, rms voltage into root 2 is the maximum voltage. In the second part, we have to calculate Imax, IRMS, and equation for the current. So IRMS is VRMS by Z. We get, again by multiplying it by root 2, we get Imax. The equation of current is Imax sine omega t plus phi. That's why this phi is being calculated earlier. Again, if XL and XC are interchanged, suppose XL is 7 and XC is 7, or XC is 3. Cos phi will remain 53 degree, but as XC is small, the EMF will lead and the phase difference for current will be negative. It would have been omega t minus 53 degrees. But now XC is more, so current will lead by 53 degree. In the next part, you have to find VR, VC, and VL maximum and their RMS values as well as their equations. So VR is, if Vmax is find, VRMS is IRMS into R, as they are in series, they will have same current as 40. We get Vmax multiplied by root 2 and the equation of VR. We now know current, so current and VR will be in the same phase. This is VR max. Similarly for VL and VC, we can follow the same route. VL will be this IRMS into XL. If we have to find the RMS voltage across the inductor, maximum will be root 2 times of that. So VL will be VL max into sine omega t plus 50 degree plus 90, as the voltage across inductor leads the current this phase by 90 degree, and similarly for capacitor, voltage will lag by 90 degree from the phase of current. In the last part, we have to draw the phasor diagram for VL, VC, VR, and total voltage current also. So we know that on x-axis we show the source voltage, which is along x-axis. Now the current leads the source voltage by 53, as we have calculated earlier. VR will be along the current, VL will lead the current by 90 degree, and VC will lag it by 90 degree. This will be VC minus VL, as VC is more. So VR is this, just shift it from here. We can say VC minus VL plus VL are in vector form as V, or you can use Pythagoras theorem if you are using their scalar values. In this method, I'm explaining the in this question I'm explaining the method of complex number. So just listen very carefully that 5 ohm resistance will remain as 5 ohm resistance, but if an inductor is there, that will be represented as iota 5 or plus 5 iota, and in case of capacitor it will be represented as minus 5 iota. Okay, so why is it so? As they are imaginary resistances, we put an iota sign with angular frequency. So omega L is 5, so iota omega L will be 5 iota. And similarly, 1 by omega C is 5 as capacitive reactance is 5, but 1 divided by iota omega C will be minus iota by omega C, which is minus 5 iota. Okay, so we get XL as plus 5 iota, XC as minus 5 iota, 5. These two are in parallel, so we have to find their equivalent using this, and XL is in series of that, so the equivalent of total will be 5 iota XL plus equivalent of XC and R, which is this. So we get equivalent as this 5 plus 5 by 5 iota by 2. Again, if you have to find the magnitude of impedance, just take the mod of that. So you must be familiar with complex number, argument of complex number. So then only you will be able to understand it. So this will be 5 by root 2 I, which is V by Z is this. Again, you can use the same complex number uh, for Z here also. You will get I as this by rationalizing. You are getting I as 40 I minus J. If you have to find VL, again use the same I 40 I minus J. XL is 5 iota, and you get the value of VL. VC and VR will be same, so we can say VC plus VL is V. Again, in the simple circuit, this voltage is VC or VR, this is VL, and this will be equal to source voltage. Sum of these two voltages will be equal to source voltage. So in this, we haven't calculated the value of VC because we have to calculate the current passing through capacitor. We have calculated the total current but not the current passing through the capacitor. So we have just taken another route to find VC. We have calculated VL, and V source is 200, no imaginary component in that. So we get VC by subtracting it from 200. VC comes out to be minus 200 iota, which is equal to VR. So IR can be calculated by this minus 40J. Similarly, IC can be calculated by this. You can also look that some of these two current IC and IR will give you the same current IL, which is also the total current. Now just drawing these at phasors, we'll have a look at that. In complex number, this x-axis is real axis and y-axis is imaginary axis. So iota terms will be represented on y, and real term without iota terms will be represented on x. So IC, as we have calculated IC as only 40, it will be completely on positive side of x-axis. IR as minus 40J or minus 40 iota, it will be here. The resultant of these will be here. Similarly, for VL, VC and VR, total voltage is this, VL is this, and VC and VR as this. So resultant of these two vectors, VL and VC or VR, we get this voltage. Okay, so we can also write their equations as IL, we know IRMS through inductor as 40 root 2, which is the magnitude of this, multiplied by root 2 to get the maximum value. It has a phase of minus pi by 4 from the real x-axis. Similarly, IC is on the real x-axis, so no phase difference, 40 root 2, and IR will be 40 root 2. 40 is the RMS value and root 2 is the factor for which we get maximum IR. Similarly, VL is IL into XL. Same, the difference between VL and IL will be pi by 2. VL will lead by pi by 2, so that's why it is plus pi by 4. Between IC and VC will be minus pi by 2, VC will lag. Similarly, VR